Hello everybody, today we are talking about experimental probability. So we've talked about theoretical probability and that should be what should happen, right? But experimental probability is what actually happens in real life when we actually do an experiment. So when we're doing this, we are going to have a new fraction, right, where the number of desired outcomes is on top and the bottom number instead is how many times we actually do the experiment. So for example, if I flip a coin 100 times and I get heads 60 times, right? That would be 60 out of 100. So let's talk about some examples that we'll see often in experimental probability. One I just said was flipping a coin. Something else we see pretty often is they talk about rolling a number cube, which is a fancy way to say a die. And of course, something we talk about a lot is pulling marbles out of a bag. So instead of talking about what should happen and what the possibilities are, we're going to be talking about how many times it happens out of the total times we actually do the experiment. So this would be something out of 100 if we're flipping a coin 100 times, something out of 20 if we're rolling our number cube 20 times, something out of 50 if we're going to pick a marble 50 times. Let's go ahead and look at some examples together. Okay, so in our experimental probability, a lot of times they give us the results in one of these little tables. I'm going to move my little head over here. All right, so this example, we have a number cube was rolled 30 times and the results are shown in this table. So this means that a 1 was rolled twice, a 2 was rolled 5 times, a 3 was rolled 4 times, so on and so forth. So we're going to write each probability as a fraction, decimal, and a percent. So again, this first one means the probability of getting a 3. Well, we rolled a 3 4 times. And that 4 is 4 out of 30 because we rolled the number cube total 30 times. So that 4 out of 30 again can be simplified. We can divide the top and the bottom by 2. So that's going to give us 2 out of 15. And when we divide that, we get about 0.13 or 13%. All right, if we're looking at a 1 or a 5, well, we rolled a 1 2 times and a 5 9 times. So if we add those together, that's 11 times out of 30 that we got that 1 or 5. This cannot be simplified, so we're just going to divide, and 11 out of 30 gives us about 0.37 or 37%. All right, let's talk about less than 4. So we're going to do anything less than 4 means a 1, 2, or 3. So we've got 2 plus 5 gives us 7, plus 4 gives us 11 again. So this is 11 out of 30, that same 0.37 or 37%. Okay, go ahead and pause the video here and try those number 4 and number 5 on your own. All right, check your work and see how you did. Multiples of 2, so we got 5 plus 7 gives us 12, plus 3 gives us that 15. So that's 15 times out of 30 that we got a multiple of 2. That simplifies down to give us 1/2, 0.5, or 50%. At least 5 means 5 or bigger, so that would be our 9 and our 3 added together for 12 out of 30, which is going to simplify to 2/5, 0.4, or 40%. Let's take a look at another example. Okay, so this time the spinner has 4 equal size sections. So picture a spinner, 4 sections, M, A, T, H, right? It's spun 20 times, so that's going to be our big total this time, and the results are shown in the table. So we want to find the probability of landing on T. Well, they landed on T 5 times out of those 20 total. So 5 out of 20 is going to simplify to 1/4, which is 0.25 or 25%. All right, a consonant is anything that's not a vowel, right? So our M, T, and H. So 3 plus 5 gives us that 8, plus 4 gives us 12. 12 out of 20 is going to simplify down to give us 3/5, 0.6, or 60%. Okay, go ahead and pause here and try the last one on your own. Okay, so again, we got 12 out of 20. So when we add that A and H together, we get 12. When we simplify, we get that 0.6 or 60%. Okay, number 2. A jar of gumballs contains the following: 2 red, 4 blue, 1 purple, and 3 green. A gumball is chosen from the jar 12 times. So again, that's the big total that we're looking for and that we want to pay attention to. That's how many total times we did the experiment. We want to find the probability of each one. So a green marble, gumball, we picked a green gumball 3 times out of 12. So that 3 out of 12 We can divide by 3 and we get 1/4, 0.2525%. All right, go ahead. Now I've done some practice, so try the second two on your own. And check your work and see how you did. The probability of not getting red would be the probability of getting the rest of these, which are 10 out of 12. So that simplifies down to 5, 6, 0.83, or 83%. Blue or green, we're going to add those two together. So blue and green together give us 8 out of those 12 times we did that total, which simplifies to 2/3, 0.67, or 67%. Okay, and so for our last example for this video, we've got a bowl of fruit contains an apple, an orange, a pear, and a mango. A fruit was picked at random, and the results are shown below. So we got an apple 3 times, an orange 8 times, a pear 2 times, and a mango 1 time. So in order to find our total, we've got to add those together. So 3 plus 8 gives us that 11, 13, and 14. So we picked a fruit 14 total times. That's going to be our bottom number of our fraction. So the probability of getting an orange, well, we got an orange 8 times, so 8 times out of that 14. We can simplify those both by 2, so we get 4/7, and 4/7 is the same as 0.57, or 57%. All right, let's try apple or mango. So an apple was pulled 3 times, a mango was pulled 1 time. So putting those together, we get 4/14, which will simplify to 2/7, or 0.2929%. Okay, pause the video here one last time and try the last one on your own. Okay, so if we want the probability of not getting a pear, we're going to add up all the rest of those, right? So the 3 plus 8 plus 1 gives us 12 out of 14, which simplifies down to 6/7, or 0.86 and 86%. All right, so hopefully we're feeling more confident on our experimental probability and how to calculate it. I hope you have a great day, and I'll see you next time.